Well, my interest in atmospheric optics began in 1993 when I took a contract job in Antarctica that just happened to fall in my lap. Um, I've been a long time Valley resident. My background was in ski areas, which got me into my job in Antarctica. And in 1999, I was offered a job on top of the Greenland ice sheet. Just my phone rang one day and someone said, "Hey, would you like to be a mechanic at Summit Station?" So an aptly named station at the top of the Greenland ice sheet, Summit. One day I was out grooming on the skiway and I noticed this complex display of atmospheric optics in the sky. There was halos, there were arcs, there were sundogs, and I'm grooming up and down this 15,000 foot skiway to land airplanes on in an old Tucker. And I see this and I just stop the cat and I get out and I start staring at the sky. I'm talking to myself. I'm cussing to myself, you know, the holy, and so that really got me. And I was hooked. At that point, I started looking in at better camera equipment and things like that. And yeah, so let me see. I'm going to see if I can share the screen and get it going right. Hopefully you guys just see, sorry, are you just seeing a screen or do you see a lot of stuff?
I'm seeing you right now.
Okay, let me see if I can do this. Does that help?
No.
No, uh-oh.
So you said
share screen. Maybe I hit the wrong share screen. Hang on here, we're gonna get there.
That's okay.
Oh, here we are. Here we are. No, that one right.
There you go.
Yay.
Yay.
Okay.
Excellent. Good job. Thank you, Tori.
All right, we knew we'd get there.
You did it, not me.
Okay, so this, my cover photo was taken on a, sorry, I'm also trying to do double screens here. It was taken on a traverse from the top of Summit Station in Greenland to Thule Air Base. Is a 600-mile traverse where this was actually the reverse where we were going back to Thule. You can see on this one, we've got halos, we've got arcs, little arcs here and halos, and a couple of sundogs here. So halos, arcs, and dogs. And so today we're going to talk about bows. We're going to talk about clouds, corona, not the virus, halos, arcs, dogs, pillars, auroras, and eclipses, distortions, and a little bit of fun with photography. So atmospheric optics are found in a variety of mediums, obviously. Water droplets from rain, fog, and clouds. We've got diamond dust, fancy word for ice crystals floating around in the air. Auroras descend on us from coronal ejections and other solar events. And the Earth's atmosphere has some weaknesses which help these events out as well. Celestial bodies can obscure one another from eclipses, shadows, heat waves, street lights, and more can cause our atmosphere to react in some pretty strange and beautiful ways. So this background photo is Harrier Hill there in the valley with a bit of an aurora. I'd like to thank Les Cowley with adoptics.co in UK. You guys should all get on that site and bookmark it if you're interested at all in atmospheric optics. Les mentored me along my way. I think I had sent him one photo and from there it just blossomed. And he kept using my photos on his website on a photo of the day that he did. Two other people are a couple of Finnish dudes, Marko Rikkonen and Jari Lumanen. And I apologize for bastardizing his name. But anyway, Jari and Marko caught on to what I was doing, and Marco would email me all the time and to say, hey, you got to do this, you got to do that. He'd give me photo tips and how to take pictures. And Yari was just as enthusiastic with it. Marco took a photo at the South Pole in 1998 that was pretty well world famous and spread around, that showed just about every halo and arc that was possible. It turns out the Greenland ice sheet is almost as good a spot as South Pole for getting these optical events. So let's see. If you guys, does anyone here know what refraction is? That's refraction. Okay, well, I don't either. Refraction is what I say when I try and say reflection and refraction simultaneously. So you guys have free reign at laughing at me when I say refraction. So, reflection involves a change in direction of waves when they bounce off a barrier. Refraction of waves involves a change in the direction of waves as they pass from one medium to another. So refraction, or the bending of the path of a wave, is like when it enters a water droplet from atmosphere to water. That's your phase change. Yeah. So water droplets can give us a variety of rainbows. And this is a reflection mist from a waterfall, obviously. And this was taken at Blackwater Falls State Park in West Virginia. Rainbows form from water droplets. This is a double rainbow. Actually, all rainbows are double rainbows, but the other one's not always visible. This is the Beagle Channel in Argentina. An interesting thing about rainbows, so there's a prominent difference inside and outside the inner bow. And what happens then is, remember we talked about reflection. The light rays enter a droplet, a single reflection in raindrops, form the primary bow or brighten the inside of the sky. So what you're seeing on an inside sky is brightened by this reflection. Rays reflected twice are deviated to form the secondary bow or brighten the outside of the sky. And so what I mean here is this is obviously brighter. We're getting light reflected back. Oops, sorry. I'm gonna try and get this back. We're getting light reflected back inward. Here's your secondary bow, and this is a horrible example, excuse me. This part is dark, but then again, this area will get reflected and lighten up the outside of the second bow. This is called Alexander's dark band. And this photo is taken right here in the Meadow Valley. All right, let's see if I can get back to where I want to be. All right, this is a nice mist bow from falls at Maui. Rainbows occur in nature when a beam of light interacts with many drops of water. Both reflection and refraction of the light play an important role in their formation. Many different things can happen as light rays pass through these drops, and most just kind of give light and diffuse out away in all directions. The rainbow originates in the special case when a beam of light enters a drop. Instead of being reflected away from the drop at its surface, it's reflected once inside. So instead of having that first opportunity back through the surface or through the back surface of the drop, it finally reflects off that and gets refracted back off the front of the drop. So it goes into the drop, refraction, back to the backside of a water droplet, reflected back, refracted back, and that gives us a rainbow. And hey, by the way, I am not an atmospheric scientist, so if you guys have better explanations out there than I do, please speak up. I'm willing to be corrected and embarrassed. Okay, so those are rainbows, and fog bows, essentially the same thing as a rainbow. So Les Cowley says, fog bows are created by sun rays passing through small water droplets. Fog bows form similarly to rainbows. Light enters in a near spherical water drop, is refracted. A small fraction is internally reflected from the opposite side and is refracted again as it leaves. So at ice cap temperatures, which this is at, water drops are unstable. They're super cool, below 0 degrees Celsius. The phase change to the stable state of ice needs nuclei in which to grow. So there's no nuclei. We're seeing a fog bow at an extremely cold temperature. And so why are fog bows white and rainbows colored? And the difference then is a rainbow formation and drop size is larger, and let me get this right here. Fog and mist droplets are fairly large compared to the wavelengths of visible light, but small enough that diffraction and interference effects become more pronounced. And when this happens and they're more pronounced, the light goes everywhere. The rainbow's well-defined, sharp colors get diffused and broaden out, and the colors turn largely white. I hope you understand that. All right, this is a fog bow at Summit Station, named with a lot of creative thought. This is the big house. We've got Summit Station on top of the ice, the big house on there. Yeah, we're pretty creative when it comes to stuff like this.
What's the elevation?
The elevation of this big house at Summit Station is 10,700 feet. We do see fog bows a fair bit, you know, even here in the valley. It's just that here in the valley, our fog bows are above freezing. Glories. And so we're getting into some interesting things. This one was another photo that Les took upon himself to publish. I'm going to show one other photo here first of a glory. This is from an airplane, and maybe a fair amount of you have seen glories from airplanes. Glories are backscattered and diffracted light from tiny cloud droplets. So freshly formed clouds have droplets that are all uniform size. They're the same, and they're the same age, and so they've all got the same reflecting or refracting values. As clouds age, then the collision between droplets and the effects of evaporation, condensation, all this mixing increase the size, and the distribution broadens, and the effect of this is it just washes things out. So the effect on glories, corona, and fog bows is effectively blur out their finer details and subdue their colors. Yeah, so I'll come back to this one. This was really wild. You know, I was just walking along and I'm seeing this, and I think I probably had polarized sunglasses on, and took the polarized sunglasses off, and I'm still seeing this, and I just think, what the heck is this? I've never seen anything like it. So I'm starting to take pictures. So multi-ring glory, 3 or 4 images are visible. They're directly opposite the sun. You can see my shadow in the foreground here. And it's produced by sunlight diffracting almost directly back along the path of the sun rays in very, very small fog droplets. And so the contradiction here with this photo and what we're seeing is the temperature was -18 Fahrenheit or -28. So in the absence of dust or other nuclei and water droplets, or nuclei for the water droplets, the water can exist below 0 C in a supercooled state. Les claims they can exist up to -40, and -40C and -40F are where C and F meet and cross. So they're the same temperature. So in exceptionally pure air like we had in Greenland, we see this. Les seemed to think that I would probably find even water droplets at colder temperatures. But anyway, quite interesting. And we'll move on to Corona, not the beer. So Corona are similar to a glory, except that in this case, the sun is right in front of me and not behind me. This is a 4-ring corona surrounded by the sun, shaded by our wind turbine. You can actually see the fog from the sun coming off the tips of our wind turbine there. So corona was generated by a thin fog of supercooled water droplets. The air temperature was -33C or -27F. Small ice crystals can generate a corona, but Les says they would be highly unlikely to be so uniform of size and regularity to generate so many rings. So I believe Les. And here's one other up close photo of that. And so, yeah, let's move on to some clouds. And this was iridescent clouds over Antarctica. When clouds are thin and have similar sized droplets, diffraction can occur and make them shine with colors like corona. In fact, the colors are essentially corona fragments. The effect is called cloud iridescence, and we see iridescent clouds here in the valley as well. This was one I decided to throw in. I called it my bird cloud, iridescent cloud over Roslyn, Washington. And a refraction bow from Kearney, Nebraska. These are sandhill cranes in the background, a very dark band of clouds at the very top of this. And on to one of my favorite clouds in the whole world, are called nacreous clouds. Not a great picture of nacreous clouds, but they're very, very rare. And nacreous clouds occur at about, I think, 10 to 12 miles up in the sky. They're not tropospheric clouds, which are what we see. That's where our weather takes place, is tropospheric clouds close to the surface. There's another, nacreous clouds are not the highest clouds in the sky. Those are called noctilucent clouds, and they're incredibly at 50 miles up in the sky. This was taken, I think, shortly coming into the summer season in Antarctica. Castle Rock is the silhouette. So we're going to move on to some ice and water, from water to ice, and see some halos and arcs and sundogs, if I can get that little thing to come up. Halos, arcs, and dogs. This is taken at Summit Station. The tents in the foreground. Yes, we did sleep outside at Summit during the summer season. I think the coldest night I spent in an Arctic oven tent was -57 Fahrenheit. Actually, I should say the coldest time I ever spent in a tent was -57. I don't think I slept much. So here we see a 22-degree halo. We have a upper tangent arc here. We have a lower tangent arc. We've got some very light sundogs here, and there was actually a perihelix circle that went all around the sky in this one. These are all pretty common halos, and I'm going to throw a little diagram in here from Les that shows our common halos. So we didn't see the circumzenithal arc which sits above my head in my photo. We didn't see that one in the last one, but we did see the upper tangent arc. We saw a 22-degree halo, a very faint perihelix circle, perhelia or sundogs, and a lower circle. Okay. And this is an all sky image of basically the same sort of thing, although there's some more complex halos in here. We do see a circumzenithal arc here. We've got a 46-degree halo. We've got perihelia at the far side of this full circle perihelion here. And it's pretty interesting when this is a full sky 360-degree view. So I'm sitting in the middle of this and I'm looking in one direction and I'll see the halos of the 22-degree and the upper tangent arc and some others, but then I turn around backwards, I see the rest of the perihelix circle, the sundogs on the far side. So it's not just looking in one direction. There were in this photo also a few other ones: Suncave Peris, and infralateral arc, supralateral arcs, subhelic arcs, Wegener arcs. But I would send these photos to Les and he would put them on his computer and do things, and he would come up with bows and arcs that I didn't have a clue were even in the photograph. So let's see if I can get back to my slides here. So Les has an infrequent halos, and in this last photo we saw the perihelix circle and the 22. We had a upper tangent arc. We actually had a I think it was the peri arc we was in there, a couple of infralateral arcs and superlaterals. Anyway, as Les says, some of these expected halos might be expected to be visible on average more than once a year. Others are once in a lifetime sights. The interesting thing about Summit Station and or South Pole Station was in spring and fall, a lot of these would happen on weekly, sometimes daily occurrences. A little better close-up shot we have over here. This is on top of Suncave Peri, and below is actually a upper tangent arc. We've got a lower tangent arc, a nice lower tangent arc. We've got infralateral arcs, a couple of sundogs. There is a 42-degree or 46-degree halo in this one. And these little lines here are just lens interaction. So those are not part of my halo. This one's probably from the same day, shows that nice lower tangent arc. The sundogs and the 22-degree halo are a little bit off here. There's probably another halo of, I think there is a 21-degree or 23-degree that would come in there. Here's our infralateral arcs. And you can see a lot of kind of dust in the air. And this is all these diamond dust items. And in fact, I'll come back. Let's see if I can find in my notes here. Okay, I'm going to show this slide one more time. So all these arcs and halos are created by a couple of different types of crystals, ice crystals. We've got plate crystals and we've got columnar crystals. We've got double columnar crystals. Sometimes you get plated column crystals. And the orientations of these things as they orient in the air on a nice quiet day are what produce these various halos and arcs, and just the way the sun is reflecting and refracting through those crystals. Okay, how are we all doing? All right, this was probably, this was one of the rarer sights I ever saw, and the only one I ever saw. So this is turning around from behind my halos, and I'm looking at the back side of this full circle perihelion. But right here, this is called a tricker arc and diffuse arcs that come out this way. And these arcs actually extend all the way around up into, not quite, they're not circular, but an oblong or teardropped fashion through the sky. So yeah, tricker arcs, don't always forget to look around. And here's an interesting one. This is a simple 22-degree halo, but what we've had here is a fair amount of these crystals have precipitated out of that and landed onto the ice sheet. It's a little bit confusing here on the inside of this halo. We've got darkness, and on the outside we've got light. So what we can see is the crystals are reflecting towards me, and the inside of that appears darker. And then the really interesting one is when everything precipitates out on a nice quiet day, and you get up the next morning and you see a halo that's only in the snow. So all of the crystals on this, a surface halo, have fallen out of the sky. Okay, and I did say that a tricker arc was probably the coolest thing I've seen, but this is probably the rarest and most unusual thing I ever saw. So Yari and Marco were my mentors, and this is called Bouguer's halo. I hope I'm pronouncing it right. The deal is with the Bouguer's is you have a simultaneous appearance of a fog bow and a halo. And what does that mean? Is it means we've got water on one side of the sky and ice on the other. So I'm working in my shop one day, and I get an email. It comes on Yari emails me, and he's all frantic. Oh, you got to get outside, get your camera, get out there. Bouguer's halo. And so it turned out I was just about ready to go outside anyway. So I grabbed my camera and wandered out, and I took several different pictures, and one with an all sky lens that does show the halo and the fog bow in the same photo. But so the deal is it's minus 33 degrees Celsius. The sun is shining through a thin fog layer, and blue sky is still visible. The Bouguer's halo rarity comes because water droplets and ice cannot coexist in a stable mixture except at one unique pressure and temperature, and that doesn't exist. I think the pressure is the part that doesn't exist. It's 0.01 C and 6.1 millibars. Above zero, ice is unstable, and below zero, water droplets are unstable. So thermodynamically, a natural long-lived Bouguer's halo and of water droplets and ice mixtures is probably an impossibility. So yeah, this reinforces how clean the air at Summit Station would be without any nuclei to turn this fog bow into a halo. And this is really, I apologize, but there is Bouguer's fog bow right across the top there. Some of these aren't showing up so well on the monitor as I can get them.
Looks good.
Show. Okay, Tari says looks good. All right. So yeah, pretty strange event. I don't think this had ever even been photographed before, so I felt quite lucky. And it turned out about a year later, I saw another one. So at Summit, it wasn't just a one-time event. Lunar Optics, the moon can produce the same optics as the sun, of course. And here we've got our lower tangent arc. We've got our 22-degree halo. We've got our perhelix circle and perhelion, our sundogs. We had a lower tangent arc and the arc above that. And there's even a little bit of a faint aurora over here on the right. This was the full sky view of that same event. And it turned out there were some fairly rare halos in this as well. You can almost see the 46-degree. You can see a circumzenithal arc here. There was actually a very rare Hastings arc that followed this kind of shadowy line in here. There were some infralateral arcs he found, and on and on. So pretty exciting for me. Yeah, and you can see it's a nice clear picture. You can see all the individual stars in the sky there. One thing Les kept talking to me about was, he said, if you ever see this circumzenithal arc go full circle, it's a rarity that no one has ever seen, but mathematically it should be there. It's called a Kern arc. So keep your eyes peeled for that Kern arc if you're ever on the ice caps. Pillars. So pillars are actually just a good indication of errant lighting. Pillars are light from the ground up, and this is street lights in Kangerlussuaq, Greenland. So yeah, we see pillars here in town. I had a nice pillar event coming into Winthrop several years ago. All right, let's move on here to auroras. We'll move from ice to magnetics. So auroras are the result of disturbances in the magnetosphere caused by solar wind. They're sometimes strong enough to alter trajectories of charged particles in both solar wind and the magnetospheric plasma. These particles, mainly electrons and protons, precipitate into the upper atmosphere. And so the resulting ionization excites an excitation of the atmosphere, emits light from various colors and complexity. The forms of auroras within the bands are usually around polar regions, but not always. Okay, so if you see a mild glow near the horizon, how do you tell if you're looking at an aurora or if you're looking at clouds? One really easy thing to do is, well, if it's through clouds, you probably won't see stars. If you see an aurora, if you see stars through this diffused light, it's probably an aurora. And what I will do, without even putting on a tripod, I take my camera out. I just hand hold it and I take this long exposure, well, maybe several seconds to a half a minute, and that will bring out your auroras and see if they're there or not. So this is a corona or a coronal mass ejection coming down straight from the sky. I'll talk a little bit more about it, but we also can have arcs that will curve across the sky, and we also have rays in these arcs that are light and dark stripes that can come across the arcs, come across the sky and reach upward in various amounts. Another coronal mass ejection at Summit Station. Yeah, these are pretty amazing. Usually the coronal and mass ejections that will accompany a regular set of auroras or flares. And I imagine maybe you haven't seen this, but you probably all know where it's taken. I think it was about 10 years ago. I took this at Sun Mountain, and this was more or less an example of a diffuse, just not, it wasn't real bright. So this was a fairly long exposure, and it did bring out a nice array of auroras. I think Wenatchee World picked this one up. Also taken here in the Meadow Valley from my back porch. So auroras are different colors. And well, here too, we see these rays. Here we see the rays. And we've also just got this whole band down here is the green, purple. So green at lower altitudes. Let me get my act together here. Excuse me. I'll just say green is usually at lower altitudes and has to do with excited molecular nitrogen and oxygen. And blue, yet at lower altitudes and is pretty rare, is another interaction. But we also will have violet, and they supposedly you can also have infrared, and but that's not visible to us. And yellow and pink can be a mix of our red and green or blue auroras. Okay, this is a picture of my backhoe. I love it. Now, this streak going across the sky is called Steve. So Steve has visited the Meadow Valley. Steve was a funny name that a bunch of Canadians came up with a few years ago for this phenomena. Everybody had earlier thought that this was called a proton arc, but I guess it would not be visible if it was a proton arc. So Steve, strong thermal emission velocity enhancement. So I'm not even sure where that goes, but Steve has visited the valleys. They can be associated with auroras, and they can be associated with some kind of strange auroras. This was a picket fence display associated with Steve here in the valley. All right. Now I'm going to play a short video for you guys. This was probably taken at about probably minus 20 F, I'm going to guess. The building in the foreground was a atmospheric study station. It was temporary. We could tow this building around. We're shooting LiDARs out the top of this little building for cloud studies, and the auroras start building. And I would time lapse these things. I just set my camera out. I'd try and make little heat protected cases. I'd be putting hand warmers in there and all sorts of things. And usually it worked out pretty well. I only ruined one camera trying to do an all sky time lapse looking straight up. And the shutter just didn't like going horizontally. And as the temperature hit about minus 40, that was the last of that shutter. So yeah.
What's the time span on that?
This time span is probably 7 or 8 hours. Yeah. And there goes Jupiter floating across the sky. All right. I'm going to have a little guest speaker next, and I'm going to let Tari talk about an eclipse we saw in Oregon, Bull Prairie. And this was 2017. All right, Tari.
I'm going to come over there so you don't have feedback.
Okay, she's going to come on over here.
So I don't know how many of you saw, the 2017 eclipse, but I remember early on in the year, Ed said, "Oh, we got to go see this. We got to go see this total eclipse." And I remember thinking, I said, "Well, here in the Meadow Valley, we're supposed to see something like, I don't know, 90 or 93% totality. Isn't that, yeah, maybe like that, isn't that enough?" And he said, "No, but I'd never seen one before." But I confess I was a little worried because there were wildfires and we were thinking about, we had to go south in order to see totality. So we were heading for Oregon and we went towards the Umatilla National Forest. But at the time, the John Day area was completely on fire. And I thought, that's all we need is a bunch of bozos watching an eclipse who know nothing about wildfires, and we get, bottlenecked somewhere and trapped. And so that's where my thoughts were. But, we just decided, let's just try it. We can always turn around. And amazingly enough, we found a campsite the night before, or 2 nights before. Beautiful, yeah, called Bull Prairie in the Umatilla National Forest, I think it was.
Mhm.
So had a little pond or lake about a 1/4 mile across with a little walking trail around it, and just completely fun family atmosphere. And the morning of, a few more people showed up from the environs, but there were maybe 100 people around this little lake, which was the only open sky that was available to us. And we watched, and Ed had gotten us all the safety Mylars, and he had things for his cameras, and we were viewing safely. But when it hit totality, for that brief minute I think we had, or 45 seconds, I actually put my binoculars up, and these coronas, I don't know,
Well,
or coronal arcs, some kind of arcs around were just amazing. And I thought, oh, well, now I get it. Now I see why you need to see totality. And there was this kind of hush amongst the crowd. And it had been interesting that while the sun was starting to get covered, it of course started to get darker, but it wasn't like a cloud coming over the sun, and it wasn't like sunset. It was, to me, a very eerie kind of dimming. And totality hit, and there was this silence amongst all of these people, and then people just started clapping. It was just, yeah, very, very special experience. So if you haven't seen one and you're wondering if it's worth it, it's worth it.
Thanks, Tori.
Back to you.
All right, and then the other eclipse we have are lunar eclipses, where the Earth gets in between the sun and the moon. So here's a lunar eclipse photo taken here in the valley. So we'll get in now to distortions. We're getting on pretty well in time here. So distortions are just long drawn out events or things that get affected on the horizon, usually by heat waves and diffraction. So this was a long drawn out sunset at Summit Station, and the sundog literally probably was 20 degrees across the horizon from right to left there. Other distortions we get are Fata Morgana or mirages. This is McMurdo Sound in Antarctica. Mirages are the result of density gradients, atmospheric density gradients produced by temperature inversions. So upward going rays from distant objects are refracted back downwards by different density layers.
So it looks like magnified.
Yeah, magnified. So yeah, another Fata Morgana, McMurdo Sound, Antarctica. Here was another distortion. This was a moonrise at Summit Station, and the heat diffracting up on the horizon there gave the moon a fairly distorted shape. All right, now this one might think, well, what the heck is he showing you a picture of his garage for when I was building it? But the oddity of this was, if you look outside my garage, shadows are going this way. If you look inside my garage, here's shadows coming off my scaffolding there. And I was sitting kind of contemplating my garage, what's my next move? And I'm looking at this going, shadows this way, shadows that way. Well, you see this little beam of light here, there's a house up above me, and the light was so intense off of that window of that light that it shadowed back into my garage. All right. Yeah, HDR halos I was just playing around one day. You can kind of bring out some of these different features. This is a lens feature, this real narrow circle, but we had infralateral arcs, and there's the parahelix circle coming out this way. All right. A very strange event that I will call an atmospheric optic. This was the IMAX crevasse on Hut Point Peninsula in Antarctica. The IMAX crevasse was named it because this is where IMAX Antarctica movie, I think the opening scene had a friend of mine falling through the ceiling of this crevasse, and they filmed it from underneath and within. This was several years later. The uniqueness of this photo is back behind me is the opening into this crevasse, which is about the size of double freezer doors. And it is in the summer, of course, the sun is always going around in a circle in Antarctica. And we took a group into this crevasse one day. It was a fairly regularly traveled crevasse, so we knew what to expect. That's why this guy isn't roped up. And but we're sitting there, and this one fellow was still down there, and all of a sudden, on the left side here, appears this bright, excuse me, getting ahead of myself. There's this bright blob, and we watched the sun blob go down right here. I wish I would have had a photo of it right there, and then go up the other side. So the sun traveled across this freezer door opening into this crevasse, and it was, I think there were 6 or 7 of us in there at the time, and we were just jaw dropped. It was like, what is going on? So very cool. Fun with photography. This was just at sunrise in the Copenhagen airport. They've got a glass dome top there, and I happened to look up, and you can see the people are straight above me, and their shadows are just straight out. Another fun one. We're getting to the end here. Okay, these are the airplanes that land on the ice. Again, transport us to the top of the ice Greenland ice sheet, or in Antarctica. They're the world's largest plane with skis on them here. And what I see here is vortexes coming back from the props. And we would see this occasionally when these planes would take off at cold temperatures. Sometimes you can even see them in the air. Little HDR fog bow over the big house at Summit Station. And for my last photo here, Star Trails. You might recognize this barn over Hancock Springs. And so Star Trails are just a series of photos that I sandwiched together. And thanks much for coming to my talk. I appreciate it. Great having you here this morning. If there have been any questions or comments, I can take them now.
That was absolutely stunning.
Well, thank you. Thank you. I hope so. Yeah.
Thank you so much for sharing that. That last photo just, whew, that's wild.
Yeah. All righty. Well, thanks, folks.
That was wonderful. Yeah. Thanks, Ed.
Yeah, you bet.
You want to stop sharing your screen, and then we can take some questions and comments.
Let's see if I can figure out. Oh. Pause share. Does that work?
At
No.
the very top it says stop share. It's a little red.
I don't see that. Oh, there it is. Stop sharing. Got it. Did I
Okay.
just turn everything off?
Yeah.
Oh, I'm next. Okay. All right.
Yeah.
Any questions from anyone? All right.
We're all dumbfounded.
You know, Ed, the one thing that occurs to me, this is Pat Lay, is I cannot imagine how you manage your photo library.
Yeah.
Your inventory must be vast.
It's thousands, but I start with dates and I put them all in folder by date, and then I make comments
Mhm.
to that as well. Yeah,
Well, it was
it's a challenge, Pat. It's a challenge.
yeah.
Yeah.
I hope you and I understand now that you do contribute your photos to science, and I'm in awe. I really appreciate your taking the time to share it with us. Thank you.
Thank you.
Yeah, I've been lucky. National Science Foundation has published a fair amount of my photos, and including an Obama era report on climate change. So yeah, kind of
Maybe
fun.
it's a dumb question, but why are bows why are these things, bows, rainbows, and all that? Why are they bow shaped? Is it gravity or what?
Why are they bow shaped?
Yeah.
Any physicists out there, Kurt? You know the
I
answer?
muted because I didn't want. Maybe.
Yeah, I was going to comment first. Can you hear me okay?
Yeah, you bet.
Okay. My name's Kurt Mobley. I'm an optics person myself. There's an excellent book called Rainbows, Halos, and Glories by Robert Greenler. It might well be in your local library. I think it's out of print now, but it's a book that has just these similar spectacular photos, and then also drawings of the path that light rays take through the ice crystals and so forth to create a particular phenomenon, whichever arc or rainbow it is. So it's a wonderful little book. If you can find a copy of it, I'm sure it's available on Amazon, at least as a used book.
Right. I've got a copy of that on my shelf, and it's a great resource. Marco Rakonen, a fellow I met, was one who went down to the South Pole with Robert Greenler, and I think his photos are in that book. And Marco also did his own, he wrote his own book a few years ago, and I do have a Finnish version of it. I haven't seen the English version yet.
So
yeah.
Ed, I can also comment if you'd like about the question of why so many of these arcs are circular. Take the rainbow, for example. The rainbow, when you draw a diagram of the reflection and refraction, the light that comes out of the rainbow droplet comes out at an angle of 22 degrees from the incident ray. And this is just an aspect of physics. So now imagine you've got a point source of light. What are all the areas that would be at 22 degrees from that point? They would form a circle. So that's the basic idea.
Okay. Thanks, Kurt. Both Kurts, thank you.
Yeah.
All right.
Yeah, there's been a history of articles in Scientific American with some good explanatory drawings, maybe now 20, 30 years ago. And there's another book by an astronomer, Dutch astronomer, where he cataloged all the atmospheric optic effects that he could find at the time. That's been a bit of a handbook in this field, as I recall.
Okay, yeah. And Les has a lot of the diagrams and ray path things on his website that Kurt Mobley was talking about. So that's an excellent resource there. And hey, I hope I did all you physicists and NASA folks justice and was worth your time showing up today. So I appreciate
Hey,
it.
I have a question, Ed. Have you ever seen anything you couldn't explain, since you do so much photography in the night skies or skies, and also out in the Arctic? Did you see any like UFO type things or things you couldn't explain?
No, those glories and things, I wouldn't have been able to explain them before I sent them off to Les.
Yeah.
In the Corona, with the one with the wind turbine, that was pretty amazing. But
Yeah.
no, Les explains them for me. I actually haven't been able to explain. No, I guess not. So I haven't
That's a
seen
great
that
question.
UFO zoom by yet. I'm waiting. I'm looking.
Yeah.
Okay, Ed, since we have time to chat, I'm gonna satisfy my curiosity. On one of the images, the second image you showed about mirages,
Mhm.
it appeared as though we were looking at a glacier. At
It
the,
was an iceberg.
okay,
I should have explained that. Yeah, that was a tall iceberg in McMurdo Sound. Both of those were.
But
okay.
the mirage makes them look
Yeah,
amplified. That's part of the
yeah,
mirage right there.
yeah.
It looks way bigger than it actually is.
I don't know if you heard Tari say this, but she was just saying, yeah, so the mirage, it amplifies and makes that iceberg look way, way taller than it really was. So,
Oh, good. Thank you.
mhm.
Ed, this is Christy. I have a question, a basic housekeeping question, and that is, what do you do, or do you follow a protocol about taking once you've got your cameras out in the cold, how do you get them back into your warm environment without things condensing, et cetera?
Yeah.
That's a great question. I'm cavalier and rogue about that usually, and I've ruined a few cameras being that way. So sometimes I just would bring them indoors and let them sit. And you're right, it's horrible, it's terrible, and ice just condenses on everything. But you put them in a plastic Ziploc bag with rice in it, things like that. Just let them warm up slowly. But it is. I would just take chances for this stuff, tell you the truth. Kind
We
of,
used to put them in Ziplocs in Antarctica, I remember.
yeah, put them in Ziplocs.
Put them in
Yeah.
right away, it seems like.
Hopefully that answers the question good enough.